Hi everybody and welcome to this month's IMV Imaging Journal Club presentation. It's a pleasure to have you on board. My name's Amy and I'm one of the vets here at IMV Imaging. And today I'm going to be chatting to you about a paper which is looking at the radiographic assessment of the heart size, a new take on the vertebral heart score. So, just in case you haven't been to Journal Club before or you haven't been for a while, we in the clinical team will review an imaging-centered journal for you once a month, and the presentation is available to view on demand, and you get a CPD certificate for attending. And we like to pick interesting topics which are hopefully relevant as well to general practice. And we love it when you get involved. So if you have any questions, please do put them in the Q&A box for us. Or at any time, you can always send us any comments, queries, or questions to clinical@imv-imaging.com. So the paper I've chosen to look at today is titled The Heart to Single Vertebra Ratio, a new objective method for radiographic assessment of the cardiac silhouette in dogs. And this was published in the Veterinary Radiology and Ultrasound Journal in 2022. So you are likely to be familiar with the vertebral heart score, and this paper just looks at a slightly different way of doing it. And this study has come from the Interdepartmental Centre of Veterinary Radiology at the University of Naples. So a little bit of background about the vertebral heart score. So the vertebral heart score method was developed back in 1995 by Buchanan and Buchler. And it was developed on the basis that there is a good correlation between the heart size and body length of dogs, regardless of the conformation of the thorax. And in this study, 100 clinically normal dogs were assessed this way radiographically, and there was no more than 4 of one breed type within that study, so a good variety of breeds. The sum of the long and short axes of the heart, expressed as a vertebral heart size when compared to the length, when superimposed on the length of the vertebral column in the thoracic vertebra, is 9.7 plus or minus half a vertebra. And there were no differences found in the study between dogs with either a wide thorax or a deep thorax, between males and females, and between right and left lateral recumbency. And interestingly, in the study, they also looked at doing the vertebral heart score in the DV view as well. So they did really dive into it. But part of me does wonder whether, with this being 1995 that this study was done, whether this was a particularly pre-pug or pre-brachycephalic era. And as we all know, we're all seeing lots and lots of brachycephalics nowadays. So just to quickly run through the vertebral heart score, the 1995 method, just as a reminder, the long axis, shown here in green, is traced from the ventral border of the left main stem bronchus, or you can also call it the ventral border of the carina, delineated by the circle within the trachea there, to the most distant ventral contour of the cardiac apex. The short axis, shown here in brown, is then traced perpendicular to the long axis at the widest point of the heart. So you've got to put the long axis on before the short axis. And you then transpose these measurements onto the thoracic vertebral column, starting at the cranial end plate of T4, as shown here and here, to compare and measure to the nearest 0.1 of a vertebra. And as you can see on the thoracic column there, the end of the long axis transposition has been marked on the corresponding vertebra, and same for the short axis. And you add those two together and express the number in terms of number of vertebrae. So, further background on the radiographic assessment of the heart as opposed to echocardiography. It's useful for vascular congestion, pulmonary edema in a more sort of quantifiable or location-specific way than with using ultrasound to scan for B-lines. It's useful for assessing the size and shape of the cardiac silhouette, also for pneumonia and tracheal abnormalities. And since the 1995 study, there have been many studies to create different vertebral heart score ranges for different breeds, and also to examine the inter and intra-observer variability, because the vertebral heart score is still a subjective assessment. So as you can imagine, there is some degree of variation between the pug and the whippet in these circumstances. And interestingly, in a bit of background reading for this topic, I discovered that Norwich Terriers have got a greater vertebral heart scale than normal dogs, which was quite interesting, given that they're quite normally sort of shaped dogs. So the vertebral heart score is not a good measurement for dogs with spondylosis deformans, small or reduced IV disc spaces, and vertebral abnormalities such as hemivertebrae, butterfly or wedge vertebrae, and all of these will lead to an increased vertebral heart score. So, coming back to the present with our current study, the hypotheses were that a single vertebra preserves its proportions with respect to the whole body just as well as the thoracic vertebral column would, measured from T4. And secondly, that the use of an inverted commas normal vertebra could allow the clinician to objectively evaluate the cardiac silhouette's dimensions, even if some thoracic vertebrae were affected by alterations. So note, it's quite important that this is looking to get an objective measurement as opposed to the more subjective vertebral heart score. So the aim, number one, of the study was to develop the new HSVR, or the heart to single vertebra ratio. Secondly, the authors wanted to test the agreement in dogs between the HSVR and the VHS. And thirdly, equally important, to evaluate the inter and intra-observer agreement amongst 3 observers of varying experience. Just for interest's sake, I wanted to get hold of a picture of a vertebral malformation. So this is from a pug, and admittedly we're looking at T12 and T13 here, but just to give you an idea of how unusual and strange these sorts of vertebral malformations can be, and would effectively, if they were located between sort of T4 and T8, make the vertebral heart score a bit more of a random number generator. So, in terms of materials and methods, this was a single center retrospective method comparison study, and records were retrieved from September 2018 to January 2021 for cases which underwent thoracic radiographs for a number of reasons, which I'll come back to later, but chiefly for cardiac screening, pre-GA exams, and staging for neoplasia. Now, this is quite an interesting point, that all radiographic examinations were obtained on awake, unsedated patients, albeit during inspiration, which is when they should be taken, and done on a CR system, a computed radiography system. The patients were restrained manually or with sandbags, the reason being to avoid rotation or malpositioning. And all radiographic examinations had to include at least one view, which needed to be the right lateral view. and a grid was used, a focused Potter bucky, and a filmed focal distance of 100 centimetres. Exclusion criteria were extensive, so as expected, they didn't want to include anything with alterations of the thoracic spine, to include the hemivertebrae, butterfly vertebrae, any spondylitis, spondylosis, kyphosis, or a small intervertebral disc space. Any inability to visualize the cardiac silhouette would exclude patients, so a pleural effusion, a right middle lung lobe opacity, cardiac neoplasia, or a mediastinal mass. Any positioning or technical errors, so inappropriate exposure or motion artifact, and then skeletal immaturity. So there were 300 radiographs retrieved and 80 met the inclusion criteria. So to test the inter-observer agreement, 80 radiographs were anonymized and submitted to 3 observers. Now, observers 1 and 2 were professors of veterinary radiology, both with a PhD, and over 25 and over 10 years of experience, respectively. So very, very experienced. Observer 3 was a professor of cardiology with a PhD and over 15 years of experience. So as much as the goal was to have a variation in the experience of the observers, I would class these 3 as very, very experienced. Secondly, to test the intra-observer agreement, which is how well each observer will agree with their own observations. When given the same radiographs to examine. 1 month later, after the first readings of the 80, a random pool of 30 of the same radiographs were given back to the same observers for the same measurements to be made. Okay, so how is the HSVR done? Using the right lateral view, you measure the length of each vertebral body of T4 through to T8, including the corresponding caudal intervertebral disc space. Then measure the cardiac long axis and short axes as per the Buchanan study for 1995. And then for each of your measurements of T4 to T8, you add the LA to the SA, the long axis to the short axis, and divide it by the length of the vertebral body plus its caudal intervertebral disc space. And this negates the need to transpose measurements onto the vertebral column. A little bit on statistics. Now, they had a professor of statistics actually do the stats for this particular paper, which I quite liked because some of the display of data was done a little bit differently to things that I've seen before. So I thought that it would be relevant to cover them. So the first point is testing the agreement between the new method and the old method for the 80 radiographs, but they only did this for observer number 1, who was deemed the most experienced. And this agreement was assessed using Lind's concordance correlation coefficient, which I have referred to herein as CCC. Secondly, the strength of the agreement was analysed via band Altman plots, which are quite interesting to look at, and I've got some pictures of that coming up. Thirdly, the error between the VHS and HSVR values was estimated using mean absolute error. And lastly, very importantly, the intra and inter-observer agreement was assessed using intra-class correlation coefficients, or ICC. So our first set of results, the agreement or concordance between the HSVR and the VHS as measured by the concordance correlation coefficient. So I've grayscaled the data on the bullet points there to show you sort of the darker thoracic vertebrae text next shows one which has a stronger correlation. And T7 has come out strongest of all of them. So HSVR for T4, the correlation is 0.94 rounded up, which is really still quite good. And that's shown actually in graph A there on the top. And that's really not sort of a loose correlation there shown graphically. And as you move through from T4 all the way to T7, the coefficients get better. And T7 on the graph there is highlighted in the bottom in purple, a very, very strong correlation at 0.98, which is quite impressive. So just remember that this is only for observer 1. They didn't display this data for observer 2 or observer 3. So I know you're all wondering, what sort of breeds did they have in this particular study? So they had 48 mixed breed and 32 pedigree. And strangely, fewer than 4 of each breed. Well, and I'll come back to that later. Results 2, the Band-Altman plots, which is testing the strength of the agreement between the old method and the new method. So again, T7 comes out really strongly. The order of the strength of the correlations has shifted a little bit between sort of T4 and T8, but it's still broadly the same. And what you can see on these graphs is the x-axis is showing the mean of both measurements, and the y-axis is showing the difference between those two measurements. The dashed lines represent the 95% confidence intervals, and the continuous lines represent the bias. The scale for the top 3, T4 to T6, is larger than the scale for the bottom 2, T7 and T8. So at first look, T7 looks to have quite scattered data, but actually they've massively reduced the scale. So HSVR for thoracic vertebrae 7, the bias is very low at 0.019. So again, T7 doing well there. Okay, inter-observer agreement. So this is how well the observers actually correlate with each other, how well they agree with the measurements that they've made. And vertebral heart score, our old measurement there at the top, has the highest inter-observer correlation, which is interesting given that the HSVR is actually supposed to, in theory, have less subjectivity, so perhaps should have a higher inter-observer agreement, but still we have good to excellent inter-observer agreement all the way through from T4 to T8. So 0.87 being the lowest is really not bad at all. And lastly, the intra-observer agreement. So how well does each observer agree with themselves 1 month later? So observer 1 is meant to be the most experienced. And as you can see, observer 1 generally has the highest intraclass correlation coefficients all the way from vertebral heart score through. And notice that T7, our favorite HSVR, is very high for observer 1 at 99, which is fantastic. And observer 3, our sort of least experienced, generally has a lower intraclass correlation coefficient, but not always, and all the way through again, good to excellent agreement. So the data is looking really, really strong. And just to remind you that observer 1 and observer 2 are radiologists, and observer 3 is a cardiologist, just for interest's sake. So, to discuss, the hypotheses were supported. The HSVR is a simple, quick and reliable method with an excellent agreement with the old method of the VHS and good to excellent intra and inter-observer agreement. So fantastic, we've got all our hypotheses supported. And it is very relevant. So there are a lot of breed issues today, more so I would venture than in 1995. So particularly with brachycephalic chondrodysplastic breeds, you have a lot of variation there. And again, with things like acquired spinal alterations such as spondylosis, these do worsen over time. And that does mean that in these patients, you cannot accurately follow up these cases with the vertebral heart score. So if echocardiography isn't available to you, you're a bit stuck. The caudal intervertebral disc space was used for the HSVR because multiple disc spaces in the thoracic column are used in the vertebral heart score, the old method. So this allows for some standardization between methods. So what you'll all be wondering is that if your T7, your seventh thoracic vertebral body, is abnormal, which of course can happen. So just a reminder of the correlation coefficient for T7 was 98% with VHS. It is possible to use other ratios from the other vertebral bodies in the order of preference, T8, then T5, then T6, and lastly T4 as the least favourable. However, T4 did not score badly at 94% kind of rounded up in terms of correlation and accuracy with the VHS. So all of these methods are really quite good, to be honest. In terms of heterogeneity, the study did mention that they were quite happy with the heterogeneity, particularly because of the number of crossbreeds that they had. However, I would argue that a lot of mongrel dogs takes out a degree of change in the shape of dogs. It kind of more normalizes the shape of dogs. And within the pedigrees, a dachshund was the most extreme example of morphology. And there was no comment on whether any of the crossbreeds were particularly brachycephalic or chondrodysplastic at all. Now, what I find really interesting about this study is that the presence or absence of underlying cardiac disease was not considered in order to increase the randomness of the sample and therefore to make it more representative of the dog population in clinical settings. Now, initially I thought, I think this weakens the study, but actually on further reflection, this is not a study to create a reference range, and this is not a study to compare clinical cases with normal cases. This study compares the vertebral heart score and the HSVR within a dog. So it doesn't matter whether that dog has a normal heart or an abnormal heart. So I think actually it's quite a good point they've made there. A comment on inter and intra-observer agreement. Observer variations when doing the VHS, the old method, vertebral heart score, observer variations in the identification of the anatomical landmarks, which are used to firstly track the cardiac axes and then to convert into vertebral units, so putting them on the spinal column properly, do create subjectivity and do create error. So particularly converting them into vertebral units is negated with the HSVR because that step is not taken. Therefore, HSVR is more objective as a result, and the HSVR is a little bit quicker to perform. And we all know that vets love efficiency. A comment on observer experience. Previous studies, and there are many, of the vertebral heart score have demonstrated that differences between observers is more strongly linked to actual identification of the anatomical landmarks as listed just above than to the observer's experience. And the observers in this study were very experienced. So it would be good to repeat this study with a wide range of experiences, even potentially using somebody novel to the method, just for interest's sake, at the bottom of the scale, with a very experienced radiologist or cardiologist at the top of the scale. And because there is no need to transpose the cardiac axes onto the thoracic spine, non-specialists are likely to benefit more from this than radiologists. And following on from that, the relevance to GPs of this study is fairly significant, I would say, because Echocardiography is not something that is accessible to many vets in terms of equipment, experience, confidence, and particularly vets who've been in practice longer are going to be much more used to assessing cardiac size using radiography than ultrasonography. So I do think that this study is very relevant. So limitations of the study, and there weren't many, to be honest. As I said before, very, very experienced observers. Is that a limitation? Is that not? It could be taken either way. And I did wonder whether there might be a bit of bias with regards case selection. So the reason for having radiographs in the first place. So there's two ways to look at this. The first one is kind of harking back to my comment on breeds. And the fact that we are not looking to create a normal reference range, and we're not looking to compare these animals with normal. Therefore, we're comparing measurements within each dog. So it doesn't really matter what's going on with the size of the heart. However, I think if we're looking to compare the vertebral heart score of and the new method, the HSVR, if we're looking to sort of get figures for that and display them and sort of publish them and go, oh, this is quite a useful method to use. Is it okay to do that with dogs that are having thoracic radiographs for clinical reasons? So if you look at the reasons for thoracic radiography of the included dogs, we've got staging for neoplasia at the top, which actually that's quite good because it's not necessarily a thoracic disease investigation that's going on. However, the majority of the other cases on that list, cardiomyopathy, cough, pre-anesthetic evaluation, are we doing those x-rays because the dog has a murmur? Tracheal collapse, regurgitation would lead to a cough, aspiration, cough, pulmonary hypertension, systemic thromboembolism, leishmaniasis, diarrheophilariasis, all could cause thoracic pathology. So these are mostly dogs with a thoracic indication from which this study has been derived. So how important is that? Not sure, definitely up for discussion. Again, still, unfortunately, there is an intrinsic variability in the ratio between the heart size and the vertebral body length between different breeds. That can never be completely negated, but this particular method should help with that. I think we need to have more brachycephalics within the study. And I wonder how much sedation or general anesthetic would affect the outcome of the study. Because with sedation and GA, the blood pressure is lower. How much does that affect the size of the heart? Unsure. I think the relevance of this study is stronger in areas of the world where sedation is not necessary because manual restraint is fine. However, I think the interpretation of the results is going to depend on what sort of restraint you need to use for your own radiographs. And I think this might be me just being sort of a bit nitpicky, but I found it surprising that given that this has come from a university, sort of a veterinary hospital university, that there was a minimum of just one thoracic image for inclusion. So I found it strange that there was only one image being taken sometimes. And even though it was the right lateral that was used for all of these, I do wonder whether it would have been good to have the left lateral and the DV or VD available, just to sort of get an idea of why you would want to use the right lateral, unless they wanted to match what happened with the 1995 Buchanan study, where they also used the right lateral, but also examined the left lateral and VD in that paper. And lastly, not sure why they only chose to correlate the vertebral heart score and the HSVR with observer 1, given that that's probably almost the most important conclusion of this study, is whether you can use the HSVR instead of the VHS. So that is everything. I hope you've enjoyed it, and I hope you have learned something. As I said at the beginning, any questions at all, please do email us at clinical@imv-imaging.com, or just type your question in the Q&A box and we will get back to you. Thank you for listening, and we will see you at next month's